Okay, we're live. So what is going on? I've got quite a bit of stuff. Minimize that. Close file. So, got the ESP32 the other day. Just plugged in my computer, so I can't move it that much. But you see, it's got a bunch of different sensors on. I'm going to add support in Cyanobyte for these different peripherals to make it a lot easier to use them, not just on the ESP32 as we see, or with it's the Arduino programming language. Arduino C, if you look top left corner, I've got a lot of windows open. I have the IDE set up. I've got this source code. It's running. I just kind of threw this together with some code I just kind of found on the internet. So in particular tonight, we've got the BH1750FVI, FVI, like to light sensor over I2C. If you take a look, if you can see, it's this sensor right here. So you see the lux has just gone up a little bit. If I just put my finger over this, now the lux is 0, back up to 13, 14. Then I'm going to take my phone flashlight, shine that on. Now it's up to 215, 340. So yeah, I mean, you can tell it's working, right? Even though it's light and it's dark in this room. The sensor works. The code that I randomly found works, but the author, yeah, great person, great code written. It's just not scaling, right? The challenge is that, you know, if I went to take this and like, oh, I don't have a ESP32, I have something else, I want to spit out something for Raspberry Pi, you can't do it because it just doesn't, the code doesn't port. And so I'm going to see if I can put together a peripheral in Cyanobyte to do this stuff. And you see I've got, you know, a couple of things all over the place. So I'm going to use generating the peripheral, write the peripherals out, generate the Arduino output for it, at the very least. Just replace this code that I've got over here, replace the source, replace the header, and then hopefully from that it's close enough to what is here that it doesn't actually break the build. You know, won't break. You know, it's just importing. It's importing the file. I also have a temperature sensor, pressure sensor on the breadboard. There is also a small display. I think the display might. I want to do all three of them, and the ESP32 is already supported through the Arduino. I also should have MicroPython support on the ESP. Maybe like a third one. I don't know yet. I do want to get all three peripherals. The display is probably going to be the hardest. It's pretty late. I just want to go ahead and do this light sensor because that seems pretty straightforward, I think. There are a few typos in this file. That should be high. I think there's another one I saw earlier. Anyway, let's get to it. Hopefully you can see, you can realize that I just have 4 windows open, and they're all open in the corner of the screen. And that's updated. It's going to be a little hard to see, so if you can watch this in high definition, I'd recommend it. Otherwise, the text is going to be too small, too hard to see. It's unfortunate, but that's how it is. I did update one of the things I did over the weekend. Was update the website. So this is the same as before, but this is nice. Now we got this nice list of goals instead of, here's like TLDR. Here's a little more info. I've got this nice kind of description. There's a diagram, and that's a little different. I have this list of supported peripherals and platforms. I'm not entirely happy with that. I kind of want to do some other data structure, some other display structure. Yeah. Yeah, okay, well, yeah. Here's a link to a talk I gave about it. So that's different, and this nice little help wanted section. This, people find the site, find the project, want to contribute. There are, a few avenues for you. Anyway, I do want to just close that. Close up some of these things here. Let me make a new peripheral, and we're going to call this BH1750FVI. YAML. And let's go ahead and throw this one up here. There's a comparison. We'll go ahead and copy. Let's find a data sheet. Let's see if you can find a data sheet really quick. Alright. This is nice. This will work. I just want to have a link to it, just in case I need it. This is a 010 of the spec. Let's copy that.
Moving on. The album being released today, and they have one more song.
Let's use the same. It probably should be cyanobyte.dev. It's not really important. This is BH1750. Who makes this? Rome, I guess. Rome. Maybe ambient light sensor, I don't know. Name is Google Inc. 2019. We're going to go ahead and use the Apache license, and this is version 010 of the peripheral version. Address type, I have to be the 7-bit, I think that's the default. The device address, it actually seems like there are 2 of them, according to this spec. It depends if the address pin, so there's 5 pins on the board. You have, VCC, you have ground, then you have SDA, SDLK, the I2C data line, and the clock, and there's the other address pin. That's just for people who want to have multiple of these devices and they want to address them separately. Anyway, that's fine. So we can just put both of them here as an array type. It's going to work out correctly. There's all these other enums. You have begin, you have sleep mode, reset. I don't think you don't need the set address, that's built in. I mean, basically just want to get the light intensity. And then some of this other stuff is not necessary because it's built in. So let's go ahead and open up our thing. This code's not very, it's not indented great. This is kind of an odd behavior. You could just use an else. I don't know. Anyway. These registers, presumably. But this does have some sort of power on mode. But we do have a way of doing that, I think. Yeah. I'm not entirely happy with the name pattern, but this will automatically give you the a begin function. Powers on description. Send a power on command to device register. I don't know. SQC write to power on. Yeah, this is odd. Because you're reading the device address, then you have that power on, which is just a single thing. This is yeah, this code's a bit I'm not really following it all the way. Let me throw up the where's all these things?
Good luck, you guys. It's going to be a very good game.
Is this really, this isn't SM bus, is it?
Yeah, I said years ago before the music guys back when
Maybe it is. Maybe I just have to really think about the way because it looks like it's all built around registers. Here's the device address first, and then the second is just the instruction. And there is no register model.
It's the midday show on 90.3 KEXP, streaming live at KEXP.org. Happy Halloween! My name is Morgan, sitting in for Cheryl Waters today on the midday show. Super happy to be here with you. And I'm very excited that I'm down in the live room with the wonderful Sam for me to take it away.
Ambient light and aspect sheet percentage. This is included below registration. This is for registration. This value is that. Here's the address, and then you send the operating code, and then you're done. So I guess the right way to do this is to say these are the registers, and then I guess if it's listed zeros after, right? If you just send, can I have a register of length 0? Would that actually work? That would be interesting. Let me try doing that. Description for measurement. I think what you have to do is a command write. Which one is the command write? I want to see. I thought one of these had a command write to them. Yeah. Or I could just use send actually, so I can just associate it. And that's really all I need to do, I think. Except, I don't know if that would work. Because here it doesn't like that. Well, maybe that's because I'm actually trying to OR it there you go. Probably want to set read write to none on the registers. I don't want people modifying these things, so that wouldn't work. Device description. Things you can do. Device. Now this is when I want command write. And reset is that one. At B7. See, I don't get some of these behaviors. If you're just inputting the mode, why you add the switch statement? I don't understand the logic behind that. This doesn't. It's ignored by the compiler, I would imagine, or it's just using up CPU cycles. And then delay. Actually, not. I don't know. Yeah, again, you have some of these weird things. Cause it'd be great to put those continuous runtime modes into an enum, but it's yeah. I don't think it's gonna work. nice that I'm able to encode some of these parameters directly into the source. Five. L. That is mode. Okay. Figure out Arduino source. So if I'm wanting to read wire request from device address length. But what's the register? I see. No, I don't. Okay. So this is kind of wonky because I designed this Cyanobyte system to work with SM bus and that very precise protocol, and it's not. It's not exactly aligning with that format. Okay. Get intensity. I think I can, as I don't know what units. As number, I don't know. I want to do variables. I want intensity. And this is a uint 16. Yes. Intensity. And we're going to try to hack this. Power damp. We send zeros and read stuff back. I guess it doesn't entirely matter what the register is, but. There's this little scaling for some reason. I don't know why there's a scaling. I could add a scaling, but I just don't understand the reason for that. Seems like some odd compensation that they put in there, but I don't entirely get why. Almost ready, but I can't do that. I need to create another register. Can I use the same? Yeah, I'll just use the same one. This has to be 16. Dummy register to represent data. Send a as the fake register address that isn't needed on this device. Call that data, and that's gonna get a 16-bit number stored in there. Return that. Hopefully this is correct. I just want to go quickly read write. Now I don't want any of these to be accessible, so I'm just gonna set these all to none. And I do need to keep these. I'll say they're writable. And that will be adequate. Now, let's actually try to do this. Peripherals BH1750FVI. Nope. Didn't like that. Type none has no attribute register. Okay, now I gotta go and remove things and see what's going on. Okay, so the function, something is weird in the functions. int is not subscriptable. If we make this a string, well, I should probably just make that 0 then, right? I can add comments in here, which is nice to have. Now let me put my commands in. Nope, that didn't that has no attribute register. Okay. Okay. So now here's the new design. It's a little that's actually interesting. Because the length is 0, it actually works exactly the way we want it to, where it sets a buffer of one length, which is just the value, and sends it, and we're done. So that is actually very clean. That's some very clean code, except it still wants us to put a uint8 in there, just because that's. But it does make me think, is it possible just to say, oh, if it's 0, just no op, right? Yeah. Take a. That's my email. Cyanobyte issues. No. If a registered device register address length is 0, do not expect to be able to write to it with any data. In the case of the BH1750FVI, it does not send both data and address, only data. As such, we should this already works for the write operation, but the input type is a input variable. It is never used. So we have our write modes, and then we have our commands power down. Right, power down 0. It doesn't work because it's being hidden. So let's go ahead and make this write only. I don't know why. I don't need the quotes, so. Okay, so we see we do the constructor, we do init on create, right, power on with a 0.
It's 90.3 KEXP here in Seattle. I'm Stephen Zinn. It's about 5 minutes past 2 o'clock, and we are ready for some live music in our studios in San Fermin. They are playing tonight at the Columbia.
We have reset, power on, reset, and we have this intensity, which does a read data. Spacing is a bit wonky, but we say write registered data. That should be 0. And then request from device address 16. Is that right? So request from device address 2. So let's do a quick wire request from. Nope. Quantity of bytes. So this was a bug in the Arduino template. Alright. And wire.read. It's the same as it's doing here. And then we do a bit shift. The implementation is slightly different, but that's implementation details. It should be working the same. Spacing is kind of weird. I can probably fix that. This is it's not perfect, but I think let's actually try to get this. UN16. This is all nice. Let me take a look at this as well. And for this nice enum for our device addresses, maybe we could label them, maybe we couldn't, I don't know. We have our 16, we have our write modes and whatnot, and everything else. Density as number. Let's just make a big as number and command reset and whatnot. So alright, so let's go ahead and I'm gonna copy these two files and just spit them out in this top little folder and replace them. And we will see if this works. If we just replace the back end. Now we've got to make sure the API is changed as well. We import the light sensor, we say begin. Right. Let's proceed device address, what is that, 35? I wonder. Okay, we don't need that. We do need to set the mode to continuous H resolution. So here's a new one. Okay. So we want to write continuous H mode. This probably might expect a parameter. I don't know. And we need to get the lux. Let's go ahead and like sensor dot. And we'll go ahead and say intensity as number. I don't actually know if we need that. Because if you look at the source code, read data should be doing the same thing, and this just passes through, right? So let's actually get rid of this. Maybe you can change this to intensity. Okay, maybe light intensity. That should just read it and print that out. It should not change behavior at all. If I did this right, it's gonna be a nope. This is a not import wire H. Yes, it does. Yeah. I had a. Huh. See, this doesn't even want. Why does this do this? I don't quite get why I'm doing it this way. And this does it. Okay, let's just have an example of how you're supposed to integrate.
Actually did happen, it was sort of a small silver lining. Our management company,
If not, allium.begin.
amazingly got a bunch of gear and we just borrowed it pretty even for 3 to cancel most of it. Well, thanks so much for your Ellis. We were just listening to it. You could, I don't know, not everybody's got a mic, but I'd like to have an introduction to our listeners.
The constructor.
Alan Tate is the singer. Ray Cassidy also sang the vocals. Tyler doing the guitar.
I feel like there's a reason why I'm doing this, and it's probably a good reason, but
Saxophone, the drums, and Rebecca doing and the floor tom. On the last song as well. When Mike gets in. San Fermin are playing tonight at the Columbia City Theater, and they got a couple more songs.
Class 2 wire has no number named end. That's what I'm doing, right? Actually, it's great to have a way of powering it off when you end. But add a life cycle end event. Auto run function if ending like on ESP32. You send the power down to BH1750FVI. And we're nearing the end of the hour and the code is not compiling. So that is not how I expected to happen at all. I can't expect one argument for your provided. So if I remove this and that, does it compile? Well, okay, there's other issues. Yeah, let me get a new issue. ESP32 focused template that does not implement wire end. Relate to options. So how does this get the... No, where do you pass in? This is the something's not working the way I want it to. Can I just pass in wire? Is that what it wants? Yeah, that is what I wanted. Matching function, yes. Now this has to go to 0 just to make that pass. Alright, moment of truth. I have this thing right here, it's saying 5. Let's upload this code. And if I'm doing anything right, it should still say 5. And I filed some new bugs, so that's cool. It's cool. There you go, it says 7. And it says 7 because if I do 7 divided by 1.2, I get 5 as a thing. So it is working, taking away that original code and the odd scaling it did. So within 1 hour, I have built a working Cyanobyte peripheral file, and you saw the whole thing. And you see if I tilt this towards the screen, the numbers should be going up. It's not. Okay. So within 1 hour, I did not build a working Cyanobyte template, but I got pretty close. If I shine a light on it, it does not change its behavior. So, it's clear output, and it's still saying 7. So, I did something right, but I did not do everything right. Let's just comment this out really quick. Upload it. Oh, I could look at the. Where's the original? If it's coming out that extra right. Oh, okay. Bring this up. It's a little happier if I put my flashlight on it.
Alright, thank you very much.
It goes up. Okay, so there you go. So as I had originally stated, within 1 hour, I built a working Cyanobyte peripheral to generate code. The code is, in fact, not 100% perfect. There is one bug and a few nits. But aside from that, it's pretty good. And it gets even better because with that, omitting that one bug, I can now go here really quickly, type in Raspberry Pi, and there you go. Now here's the Python class. No extra work had to be done to port it to Python. Or if I wanted to go ahead and say, I know I want to get the documentation. Here's a markdown file with all the data. So, pretty neat. Of course, I need to figure out this thing. Might have to re-implement this as a command instead. But how do I do that? I don't have support for that. Or do I? I don't. No, I do not have a way to arbitrarily request to read some data. So, is that the end? That is the end. Alright. End of the music, so I guess that means my hour is up. I'll admit, I'm a little disappointed that I didn't get all of the way through this. I can make a new bug. sudo yaml command to arbitrarily read in the case of the BH1750FVI light sensor. You cannot write read from a register address as its data only. This means that you cannot do a standard read on the light intensity. Rather, we need a way to read data arbitrarily off the bus. And somehow, without sending the register, what if maybe I could embed this into the register itself. If I had a new property, it's like, don't send the register address. That's a bad name, but you know, you kind of get the gist of what I'm saying, right? You don't send that, and then you say, oh, you don't do it, then don't do it, and then that's fine. So let's just submit. Actually, let's go ahead and paste this code snippet. Basically, we don't want this line, and I think we can get there, but this is going to have to wait until next time. Now, in the past hour, we've created a few new issues. That's fine. It's fine because we've got some stuff that we can improve with. It makes the whole thing a little better. Yeah. Alright, well, I think I'm gonna go call it a night, and tomorrow, Wednesday or whatever, we will address all of these issues. And none of these should be that difficult to do, I think. So we'll just do them all. Maybe we have to take a few steps back first. Tackle each one of these, and then go back to the light sensor, and then I'll show you how it will generate the perfect code without any of the small issues I had to fix later on. Alright, good night.